So number 1 was talking about what, 2 dimes and 2 pennies? Correct? What's the probability of any of those coins landing heads? Is 1/2, right? And since there are 4 coins to toss, we need to represent each of those 4 coins with its own probability. Each of those is 1/2. 1/2 times 1/2 times 1/2 times 1/2 is equal to 1/16. That's the answer number 1. Okay. Number 2. If you roll a red and blue cube, faces of both cubes labeled 1, 2, 3, 4, 5, 6. What's the probability he'll roll a 6 on the red and a 4 on the blue? So this one's a little bit confusing simply because they put red and blue cube. Does that really matter? No. All that is a way of just identifying which cube is which. So we say, what is the probability of getting a, what is it, red 6? So how many red 6s are there? 1. Out of how many sides on the red cube? 6. Okay, then we also want the probability of a blue 4, which is still 1/6. What are you going to do with those 2 probabilities? Multiply them together. 1/6 times 1/6 is 1/36. That's it.
But there's more red spaces and there are more blue spaces. Does that give it a easier chance?
What do you mean?
Because it says it's like a cube, and it only gives you that 2 colors. That means like half the cube is blue, half of it is
No. They're saying there's one cube that's blue and one that's red, but they're both exactly the same. It's just like saying this is cube 1, this is cube 2. Okay? All right, number 3 is a little bit trickier. It does give you a hint what part of the total area is the shaded area. Well, if we find the area, what's the area of the shaded part? 1 times 3 is 3. What is the total area? 20, which means what is the unshaded part? 17, because 20 minus 3 is...
But how is that a probability?
We're going to get there. Okay? Which means, how many total parts of this rectangle do we have?
17. 20.
20. Okay?
But 3 we can't use.
And if we want to know what is the probability of getting one in the shaded, is what out of 20? 3. How about the probability of getting something in the unshaded? Is 17 over 20. Okay?
So those are the answers.
That's not the answer. Those are the individual probabilities, but it says we want the first point to be in the shaded and the second point to be in the not in the shaded. So what do we have to do with 3 20ths and 17 20ths? We have to multiply them together. So 3 over 20 times 17 over 20. I'll do the bottom. And then 17 times 3 is just 51. You can't simplify that, so you're done. Okay, so all these every single time, in case you haven't quite picked up on it yet. The probability of one event, probability of the second event, and then you just multiply them together. Okay? Absent kids, okay? Okay. All right, number 4. Mary tosses 5 two-color counters that are yellow on one side, red on the other. What's the probability all of them will land red side up? I know. So what's the probability of the first one to land red? 1/2. What's the probability of the second one to land red? Still 1/2. How about the third one?
1/2.
Hopefully we're noticing a trend here. The fourth one?
1/2. How? My favorite number. 1/2.
Because no matter how many times you flip it, does the first time you flip it change what's going to happen the second time? No. So our 5th time, the chance of it landing red would still be Okay. Now we just need to remember that 1 times 1 times 1 times 1 times 1 is not 5. It is indeed 1. And 2 times 2 times 2 times 2 times 2 is not 10, but 32. And that's your answer. All right, a couple follow-up questions that aren't on your paper, but we can answer them anyway. Is this a single or compound event?
Compound.
Why is it compound?
Because there's more than whole number.
Because
There's more steps.
anything you have to multiply is automatically compound. Okay? The stuff we did the very first day, those were all just single. So more often than not, your answer is compound. Okay? Is this dependent or independent? This is independent.
What's the difference again?
Because we said, does this second roll or flip depend on the result of the first flip?
Yeah. No.
No. Okay? Since they don't depend on each other, that means they're not dependent, which means they're the opposite, which is independent. Okay. I don't know. All right, mark an X in the space if it has probability 1/2. So does tossing a penny, chance of landing heads, is that 1/2?
Yes.
Yes. How about rolling a 3 or a 5? No. How many outcomes are there? 6. How many are favorable? 2. 2, 6 simplifies to 1/3. Okay. Some people wonder about the next one. Selecting a red tile from a bag of tiles that has 5 red and 5 blue. How many possible outcomes are there? 10. If we want a red tile, how many favorable outcomes are there? 5. 5 10 simplifies to 1/2. So X. Selecting an even number from a bag of tiles numbered 1 through 10. So how many favorable outcomes are there? Or I messed that up. Thank you. There are 10 possible outcomes. There are 2, 4, 6, 8, and 10 are even numbers, which means there are 5 favorable, and that still simplifies to 1/2. You know, there are still some people who are like, what are the even numbers? I don't know. That's crazy to me. That odd numbers you can't divide evenly by 2. Okay. All right. And one more we'll do together. The sum of the probability of an event happening and the probability the event will not happen is always equal to 1. We know that. If the probability of the event occurring is 45%, what is the probability the event will not occur?
55.
How did we get 55?
Because we divided 100.
Not divided.
Subtracted.
100 minus 45% is 55. Which is more likely? The event happening or not? Not. Okay? Try the rest on your own.